Okay, so far we have the pen working again here. So we have 0.20 milliliters. We've got 2.5 milliliters. And we're going to dilute this with this part right here, dilute up to 10 milliliters. So always going to have 10 milliliters. So what we need here is molarities, not moles. So we're going to take 4 times 10 to the minus 6 moles, in this case, of the SN minus, and we divide that by 0.010 liters. And that gives us a molarity. And then we do the same thing down here. So we have to take this, divide that by the 0.010 liters to get molarity. And that's how you calculate what the molarity is of the SCN minus, the NO of the iron 3 plus, and we don't have to do it for the nitric acid, right? You don't have to know what the concentrations are in this case. If you need to, you can do the same thing. We're going to add, approximately, well, it's going to vary from 1.5, from 4 or 6 milliliters down to more than that. Then the other part of this table you have to fill in is what is the equilibrium concentration of iron thiocyanate? This is where it's going to pay to have read the lab. So if we look at that lab, this is the table 1 you've got to fill in. You've got to put this in. And what you have to do is assume, in this case, that it all reacts, that you're going to make all iron thiocyanate from these. And so you're going to figure out what the limiting reaction is and how much you can actually make in this. And you can even see that happening if you do this down here. Figure out these concentrations, you get this as your final concentration, and that only happens if you go to completion. And that's what you're assuming in this first step. So I have actually scrolled here in the beginning of the procedure. It tells you this. It's right here, number 3 under procedures. Prepare standard calibration curves, and it says in this part of the solution are prepared so that initial iron concentration is much greater than the initial SCN minus concentration. That's what we just calculated down here, right? We have a very low amount of SCN, a very large amount of iron 3 plus, and under these conditions, the equilibrium position lies far to the right, and it can be assumed that essentially all of the SCN minus has reacted to form iron thiocyanate. So whatever your concentration is of iron turns out to be whatever it is of the thiocyanate, not the iron, that's the limiting reactant. That is what makes your product. So that's how you fill out that table over there. So that's how we make our standard curve, essentially, to make iron thiocyanate that you'll prepare a standard curve from. You know these concentrations. You then make the absorbance readings and make a standard curve like you've done in other labs. But now we go down here, farther down into the laboratory, and in your calculations, what you're going to do is you're going to make up, see, there are much different concentrations in table 2 here, and the concentrations are going to be fairly similar. And now equilibrium sets in, and you won't necessarily go to completion. So what you'll do is you'll make a known concentration, solution A, a known concentrations of B, C, and D of each of these two, thiocyanate and iron nitrate concentrations. You can calculate what those concentrations are in molarity, and then you let them react. And you, by absorbance reading, by putting then that finished reaction in the spectrophotometer, you measure the absorbance, which from your calibration curves allow you to find out what the concentration of the iron thiocyanate is by direct measurement. Now what we're going to do in the next part is once we have this, how do we calculate what the final concentrations are of the iron and the thiocyanate? So that's the next part, and I'll do that now.